Hi guys, welcome to question 3, the final part of the 2023 calculus mock exam. Let's get started. A charter bus on the open road travelling away from its first stop of the route has received an instruction to turn around and return to the depot. Bus can be modelled by this. Part 1. What is the acceleration of the bus 1 second after it turned around? Right, all we have to do is just derive this, because we know kinematics. It sort of follows a sequence like this, where an acceleration, if we have the distance and we want to find the velocity, we derive, and then if we want to find the acceleration but we have the velocity, we just derive, and if we want to work backwards, we just integrate. Okay, so all I'm doing is I'm taking this velocity equation and I'm going to differentiate it. So I'll just write it out here. So a of t is going to equal 2 minus 2/5 t. We're given the time of 1 second here. So all we got to do, when t is equal to 1, equals 2 minus 2/5 1. So a is going to equal 1.6 meters per second. Alright. And that's part I done. Next one. The bus travels back past the first stop 17 seconds. We've got a new time value now. After it turned around, how far from the stop was the bus when it initially turned around? So we've got to anti-differentiate, because now we want this stands for the distance equation, by the way. We just write it as S. So we've got to go backwards, which means we've got to anti-differentiate. So if I have this equation, to anti-differentiate, we just add the power and divide by the power. So S of t, it's going to equal t squared minus 1/15 t cubed plus c. Don't forget that plus c. Now in kinematics, we usually assume c is 0, unless the question gives us a piece of information that tells us it's not 0. We usually assume when t is equal to 0, s is equal to 0, so c is equal to 0. So when s is 17, we just plug in the values. I'm going to rewrite this as negative 1/15 17 cubed plus 17 squared. Just make sure you rewrite it out, because if you do it in this form, I think you're going to get a wrong answer. You're going to get an answer of, you should get an answer of 38.533. Now, it might be negative, but that's okay, because actually the negative tells us it's basically turned around and went the other direction. So don't think it's wrong if it's negative, because it's actually right. But we're obviously going to write it out positive, because that just makes sense. So we can also write a little statement like, initially the bus, also write the unit, meters I think. I think it's, yeah, meters per second. So just write meters. Initially the bus was 38.53 meters away. Okay. So for this question, if you have got the correct c value, so you've made a statement that c is equal to 0, and you've also found the correct distance, so this part here, you would get a merit. You must also have the unit, so no unit, no merit, or no meter, no merit, by saying. For achieved, there just needs to be some evidence of anti-differentiating, so this part here would be achieved. For the earlier question, to get achieved, you just need to get 1.6 meters per second. Alright. Next question. Okay, another one of these draw the graph ones, so pretty easy. The gradient function of a curve is shown below. Okay, notice how this has a little dash in it, which means our new graph, I'm assuming it doesn't have a dash, yep, That means this is the anti-differentiated version. Now you know when we anti-differentiate something, we add 1 to the power. So this x squared is going to become x cubed, which basically means it's going to go from a parabola to a cubic. And this is a positive parabola, which means we're going to have a positive cubic. Now all we need to do is find the x-intercepts, because that's where our turning points are going to be. So 1 there and 1 there. So if I go down here and mark it out, that's at around 1. So if I just make a little mark, and remember n's positive, so it's going to be, this is going to be my minimum, and the maximum, the local maximums were, that's about 5. So 1, 2, 3, 4, 5, we'll just make it here. So our graph will look something like this. Oh, okay. Just make sure your turning points are in the right spot, or else you won't get the full grade. And make sure it's a positive. So for merit, you must have a positive cubic. So it's got to be positive. And correct turning points. So correct TP. That's merit. For achieved, you literally just need to have a positive cubic shape. So this part achieved. Okay, next question. A large pool of water is slowly draining out through a clogged sewer. The number of liters of the model of water can be modeled by this. Find the rate of change of volume with respect to T when the number of liters in the pool is 1449. Okay, we are given another piece of information. So the first thing we need to do is find T, like always. We always got to find the time usually. So to do that, this actually is a quadratic equation, I can see. So that we're going to make all of this, and they've given us the volume of 1449. So I guess we just go 2100 minus t squared minus 10t equals 1449. If we rewrite it out and simplify it, we should get t squared plus 10t. 1449 go to the other side will become a minus, so it will be actually this will go to, it's just be negative 651 equals 0. So if you put this into your graphics calculator or quadratic formula, you will get t either equals 21 minutes or t equals negative 31 minutes. Now obviously t must equal 21 because we can't have a negative time. So it's not this one. Once we have our t value, we go back up to this equation and we just differentiate it because we want to find the rate of change, which means the differentiated version. So we're going to do v dash of t equals negative 2t, because that 2100 goes away, and minus 10. Plugging in our values, t is equal to 21, that will equal negative 2, 21 minus 10. And that will give us v is equal to negative 52. And we've got to have some context or else we won't get the full mark. So you could say like, the hole is draining out at 52 liters per minute. Right, we've got, because this is the liters here and minutes. Okay, for merit you need to have the correct rate of change found with units or context. So this would be merit. I could also write email here. That's also merit. Achieved is you've correctly derived it or time calculated. So this can be achieved or this can be achieved. Okay, that's question C done. I'm going to do question D in another video because this question is a very difficult one. It's quite a long one and it's also a double excellence question. Go figure. So I will do this in another video. I'll probably just do this whole question in one video because this is the last question of the whole exam. So yeah, any questions, leave a message and I'll finish this question off soon. Cheers.